Chapter 9, Section 3 is called PERT. So the difference between yesterday and today is yesterday was exponential growth and exponential decay at a certain time, and today is continuous. So the difference, okay, is this nice letter E, and it's always going to be used when you see the word continuous. Okay, so continuous means we're using a different formula, very similar to yesterday, only that E helps us with the continuous factor. Okay, so our formula is going to be A equals PE to the RT. Okay, P stands for our initial amount. Okay, E is just E. That's a button on your calculator. Okay, and I'll show you where that is when we get to that point. R is your interest rate as a decimal. Okay, so very similar to yesterday. Okay, you're going to turn it to a decimal, so you're going to divide by 100. Okay, but today there is no adding, okay, or subtracting 1. It's either positive for growth or negative for decay, so no adding or subtracting 1. Okay, and then time is in years. So pause this so you can get all of that down. We'll move on. Okay, so it says go ahead and graph this and name the properties. Okay, so first of all, I'm going to go ahead and look at this. And I know that this is 0.08, and I know that that is positive. So if it's positive, that means this is going to be exponential growth. Okay, I know that it's still going to go through this initial amount here, so I know it's still going to pass through 0.4. I know that this decimal, 0.08, really means 8%, so it's an 8% growth rate. Okay, so if I wanted to go ahead and graph that, I would make it go through 4, okay, and then it would be an exponential growth going up like that. Okay, and it would have the exact same properties as it did yesterday. So the domain would be all reals, my range would be greater than 0, and I would still have an x-axis as the asymptote. Okay, so okay, so same idea as yesterday, just looks differently. So you just have to be able to pick out those pieces. Okay, so just pick them out, and I think you should be fine. So the second example says f of x, okay, again, if you can't remember, that's just a y, equals 6e to the negative 2x. So if I wanted to look at this first part, I know that's my starting amount, so it's going to go through 0, 6. Then I look at my growth rate, that's a negative, okay, which means this is going to be exponential decay. Okay, and the growth rate then is 200%, okay, because that's really a percent, so 200% going down. Okay, so it's decreasing by 200%. Okay, so looking at that, now let's try and write some of our own. So if $850 is invested at the annual interest rate of 6% compounded continuously, okay, so there's that key word that means we have to use the formula from today, which is PERT. Okay, so if I know I originally invested $850, that would be my p-value. E is just E. R is my interest rate. Again, you always have to take that and divide by 100. So that will be 0.06. Okay, it's growing, so I kept it to be a positive 0.06. And then time is 10, so then 10 years. The great thing about this is you don't have to worry about plugging it in right or wrong to your calculator. You're just going to plug it on all at one time. Okay, so you're going to go 850. You're going to find E, and it's a small case E. Okay, and if you can see my calculator, this is right here, where I'm circling right here. It's going to be above the ln key, and it's going to say E to the x. So I'm going to hit second ln, so you're going to see, excuse me, I hit it twice. 850 second ln, so you get an E to the, okay? And then you just pipe in 0.06 times 10 and close your parentheses, and there's your answer. Okay, so you're looking for this little E to the, okay, and it's going to be by your ln, and you're just going to have to hit second first. Okay, so our final answer here is $1,548.80. Okay, so just plug it right in like that, and I don't need to see any work from there. Part B says suppose the population is continually, okay, so continually is the same thing as continuous, decreasing. The population was 12,000 and is dying at a rate of 4% per year. How many are left after 12 years? Okay, so continuously means PERT. So I have A equals, P is my starting amount, so that's my initial population of 12,000. Okay, E is just E. Dying means it's going down. So I'm going to take my 4% divided by 100 and make it negative. So negative 0.04. Okay, and then after 12 years, we times 12. Okay, so make sure you realize the negative makes it the DK, and we're not adding or subtracting sums. Okay, again, you're just going to plug that whole thing into your calculator just like you read it, and if you get a number less than 12,000, oops, this is not dollars, I'm sorry, 7,425, okay, people. So make sure you just type it in just like you see it, and you're using the right E. It's a lowercase e. Okay, part C says in 1992, the fastest growing state was Nevada. The population was growing by this equation, where P is the population in thousands, okay, after 1992. So I like to highlight things that are, underline things that are good for me to remember. Okay, so just picking out the information. The initial, okay, the initial amount is always the first thing after the equal sign. So 1,336,000, okay, because we're talking in thousands, okay, was the initial population. The growth factor, okay, so that's your R, that comes from right here, 0.05 would be 5%. And then what will the population be in 2000? So then I'm going to use the equation, but instead of T for 2000, again, because I underlined years after 1992, I know that that's 8. Okay, so 2000 is 8 years after 1992. So you plug that in and you should get about 1,993,000. Okay, remember to label here. Okay, 1,993,000 people. Okay, so also reading the information is good. Example D, same idea. Okay, we're reading the equation. Certain radioactive substance remaining after T years decreasing according to this formula. So label. Okay, so even though there's different variables, it means the exact same thing. Okay, so this part is usually our P value, which means our starting amount. Okay, this number, the L, is usually your ending amount. Okay, E is just E. This number is your growth rate. Okay, and T still stands for time. So no matter what variables they throw at you, it's going to be in the same exact order. So just rewrite it, okay, if you want to, or just label it. So if we were going to rewrite it in variables we're familiar with, this would say A equals PE to the negative 0.0001T. Okay, so don't let it fool you. Okay, you can just imagine if you want, or rewrite it if it's easier. Okay, so the rate of depreciation, well, the decimal is negative 0.001, so that is 0.01%. Okay, so you're moving that decimal 2 to the right when you're talking about percent. It already said depreciation, so we're not going to label it negative because that would be making it a double negative, which would actually make it positive. Okay, so when it says the rate of depreciation, you just tell me the percent. Letter C, if 2,000 micrograms are left after 6,000 years, how many were present initially? Okay, so this one we're working backwards. So if 2,000 is how much I'm left with, okay, that's what I'm going to plug in on the left-hand side. And I'm actually just going to use this equation because I think I'm more comfortable with it, so no big deal. So PE to the negative 0.0001 times 10, and that was 6,000 years. Okay? Now I'm trying to solve for P. Well, in my calculator, I can find this whole thing, okay? I just do E to that number, okay? Because that's what it is, it's a number. So that's going to give me 0.5488. So now I have 2,000 equals P times 0.5488. And if I'm solving for P, this should make sense to you. We're just going to divide each side by 0.5488. So P will equal about 3,644.24 milligrams. Okay, so again, E is just a number on your calculator, so just plug it in and then divide. All right, and then one last example is talking about the power P of a satellite given by this equation, where T is the time in days. Okay, so it's just reading and pulling out from the given equation. Okay, so the first number after the equals is always your initial. So the initial power is 50 watts. Okay, is this an example of growth or decay? Okay, so that's when we look at our growth rate. Well, here we've got a negative. Negative means decay. Okay, so I can say decay because exponent is negative. Okay, and then part C, how much power will be available at the end of 2 years? Okay, so just read carefully. Time in days. So I want to know how many days are in 2 years. So that would be 730, 365 and 1. Okay, 1 year and 730 in 2. So again, type that straight in, okay, and you should get about 2.697. Okay. So today, continuous growth and continuous decay, very similar to yesterday, just a different equation. So write down if you still have questions about any of this and bring them to class tomorrow.